Welcome to Supercool, the show about low-carbon innovations now scaling. Each week, we talk with the founders, CEOs, and executives whose companies are winning customers, growing revenue, and capturing market share by turning carbon-cutting ideas into competitive advantage. This is the rise of the low-carbon economy, a multi-trillion-dollar transformation already underway. I'm your host, Josh Dorfman. The conversation around data centers and AI is everywhere and moving so fast that, frankly, we're all just trying to catch up with it. It's like the ground beneath us is no longer stable as we race toward a future we didn't even know we were running toward just a few years ago. At Supercool, we cover the low-carbon economy as it scales up. And now it seems nearly every week, some part of that conversation ends up being about AI. Because nearly every company scaling climate innovation today is integrating AI in foundational ways. In episode 72, I spoke with Brad Pilgrim at Parity, a company using AI to remotely optimize heating and cooling in massive skyscrapers where the need is high, but on-site teams are small. In episode 69, I spoke with Albert Johnson at Crux, which uses AI to vastly improve the data room experience, which speeds up how quickly capital gets deployed to solar projects and advanced manufacturing. And in episode 62, I spoke with Astrid Atkinson at Camus, which harnesses AI to help utilities do the near impossible, bring coordination to grids moving from thousands of participants to millions as distributed energy resources increasingly connect. On top of that, we recently toured an AI data center in Las Vegas with Schneider Electric, the largest data center infrastructure provider in the world. We walked through these massive buildings, loud, filled with racks, more security guards than actual operators. Schneider's doing off-site prefab of entire cooling systems because at the gigawatt scale these factories are now reaching, it's simply not logistically feasible to build on-site. And they're using digital twin technology to model everything in software because the systems are now so complex. And the thing is, data centers have always sought to operate as energy efficiently as possible. And for decades, that meant buying better hardware, more efficient chillers, smarter cooling systems that delivered consistent improvements. But there's a ceiling to all that. You can only make a chiller so efficient until you reach the hardware's limits. Today, I'm talking with Jasper de Vries, CEO of Lucend. His company takes a different approach. Software that optimizes all the operational complexity inside data centers, the cooling systems, power distribution, and the mechanical infrastructure. When Jasper first got into data centers 7 years ago, he encountered the butterfly effect, and he was hooked. Meaning, something happened on the roof of a data center facility, and he could see it ripple through the entire system all the way down to the valves in the server rooms. I mean, we're talking about 300 billion sensor readings, too complex for humans to even track. So Lucend takes all that sensor data and generates recommendations for the operators inside the buildings. The results? One of their facilities cut power usage effectiveness, or PUE, by 40% in a year. And that's $4.3 million saved. It's a solution already deployed globally in 50-plus data centers: Chicago, Singapore, Frankfurt, Paris, Melbourne. And every new facility feeds insights into Lucend's platform to make it smarter. Different climate zones, different facility designs, even one that relies on river cooling. Jasper calls it their suitcase of optimization models that grows with each deployment. And here's what most of us miss in this AI conversation. We're all focused on operational energy, meaning how much energy these AI factories need to run. Yet Jasper sees another glaring issue, what's known as their Scope 3 emissions, or all the embodied carbon emissions in all that new hardware that gets made to run these facilities. Microsoft's own data showed Scope 3 emissions were blocking the company from hitting its 2030 climate targets. And that's because this build-out is moving so fast with so much new hardware. JP Morgan estimates it will amount to $5 trillion of new build-out by 2030. And that's just off the charts unprecedented scale. And making all that stuff has a massive carbon footprint. So Lucend addresses both issues, operational efficiency and embodied carbon, extending hardware asset life through software that reduces physical wear on components. So while the world is racing to build bigger AI factories, Jasper's goal is to make all of them far more effective, efficient, and profitable. And once his team lands on site, they can start delivering results in just 6 weeks. Here's our conversation. Jasper, welcome to Supercool.
Thank you. Pretty excited to be here.
I am so excited to talk to you. We increasingly talk to companies whose solutions rely on AI, whether it's a heating system or school buses that become more efficient on their routes because AI is helping to drive that type of innovation. We talk to all of these companies leveraging AI. We've yet to really talk to a company that's actually leveraging AI to enhance AI and AI data centers and really in the guts of the infrastructure where Lucend operates. And so, one, thank you for joining me. I appreciate you being here. And I'd love to give you a chance and our audience a chance to hear a little bit about your background and how you arrived at Lucend, which, as I understand it, is a relatively new company. I mean, it got started just a few years ago.
Yeah, just a few years ago, but let's take a small step back. My background is in data. So after graduating, I never did anything else except for work in analytics. Started working with what we now call AI somewhere in 2012 when Jeffrey Hinton proved that neural networks are actually pretty good in what they promised. And before that, it was theory. So taking that background in the AI space, I stumbled upon an opportunity already almost 7 years ago, to be honest. So I had my second company at the time, and I was approached by this data center, a big one in Europe at the time at least, and with the ask, what can AI do for us as a company? Pretty forward thinking, and it was a consultancy assignment. I didn't know anything about data centers, like most people, until like 2 or 3 years ago. And I was so fascinated by two things. One is the complexity of this data center and the fact that nobody knew at the time what data centers were and how fundamental they are for even this recording, right? And a second thing, so I had used AI in a number of fields, from healthcare to insurance to food chains, also in marketing. And here I was like, hey, this is the potential for this is so big, and for the first time it was a use case that data could not be used against people, meaning it's only about sensors. It's not about the data, is not related to any people, does not tap into all these privacy concerns or whatever. It's just machine data. And using this machine data, there's only use cases for the good, right? There's no downside to this potential. So those two things actually, I got really intrigued, and fast forward 7 years and we're now a great company, great people on a great mission.
I love it. So in my preparation to get ready to talk to you, I learned a new term, which I understand is a key metric for Lucend. I learned power usage effectiveness, PUE.
Yes, the magic words.
The magic words, which sounds like this is the thing that people who run data centers think about an awful lot, like how much energy are we using? How do we squeeze as much data and compute out of our factories for the least amount of energy? And how do we optimize? And so I read about these incredible stats like Lucend, 40% reduction in power usage effectiveness, massive reductions in water consumption. So talk us through the offering. Like, what does your company do?
The foundation of what we do is every data center globally has an awful lot of sensors. Some more, some less, right? But we take in all of this sensor data from all of the mechanical and electrical infrastructure, like fan speeds, valve openings, floor pressures, power consumption, obviously, temperature set points. And we use very specific machine learning to do three things. Identify symptoms all across the data center infrastructure. The second thing is we combine those symptoms into a diagnostics. Hey, this is what's actually going on. And the third, then we generate very specific recommendations for any of the operators to point them towards very specific actions like, hey, if you do this, you're able to save this amount of energy, water, or CO2. And what's really beautiful is the adoption by our users. One of our users was able to, in just 1 year, to reduce the PUE by 40%, for example, from a PUE from 1.6 to 1.36, totaling $4.3 million in saving in just a single year. So I think this is a really beautiful example how an impact on sustainability also ties into benefits for our customers. I can talk much more about it, but I'm curious to two more questions or responses from you.
Yeah, exactly. Okay, so we were recently in Las Vegas with Schneider Electric who has a lot of infrastructure going into AI factories or AI data centers. And we toured a AI data center from Switch, big AI data center company, and went through all their buildings, these huge buildings with these massive racks. When you're walking through that building, without knowing what's going on, it kind of feels like, all right, I mean, I've seen this now in tons of movies. I get it. There's like computers in these racks. And in and of itself, it's not, I mean, this may be weird to say. I wasn't like, oh my God, this is so fascinating. Like, I'm looking at racks and it's loud, right?
Yeah.
And there's not a lot of humans in there, at least from what we could see. When you talk about all the sensors, that means that most of that technology in there, though, you can take a snapshot of what's happening with all those machines. Can you help me understand that more of where's the data coming from?
Yeah, let me ask you one thing. Did you also visit the non-server rooms, the mechanical equipment rooms, where they house the stuff that actually make the servers run or provide the energy? Did you also visit them?
We walked those hallways where you could see the massive machines where electricity is coming in and it's getting monitored and metered and sent out. But no, I don't think that we did get access to that.
So before, my background is not mechanical or electrical engineering, right? It's data. But to me, the infrastructure behind the servers, right? The infrastructure that make up this data center is just this huge, big machines. A lot of thinking was put into this and still is by the likes of Schneider, for example, right? To me, it's just immense, the complex system that you're able to build with all of this hardware. And that's where part of my fascination comes from. And this is also where my question comes from. Because the servers, yes, they're, to be honest, I agree, quite boring, right? You just walk there and it's up, you don't see anything, you see a few lights blink. But when you get a look behind the scenes of those data centers and just picture the immense complexity to make everything work in sync, to not only keep the data center up and running, but also, right, why we're here during this podcast, but also make them more optimized, make them more sustainable. How you do this, that's, to me, really, really fascinating. And so what we tap into is a lot of the data coming from these types of machines, the machines that actually make up the data center. So apart from the servers, make sure you have the power, make sure you have the cooling, make sure you have whatever it takes to have those servers run. And being able to optimize that complex system, because essentially it's a complex system where something happens on the roof and it has an immediate impact on the valves of pieces of hardware that are trying to cool those servers that you passed, right? So being able to tap into that complexity, understand it, just a little bit more understanding allows for so much more optimization potential. Yeah, that's driving me, that's driving the team. And it's a very, very good way to spend our time, so to say.
It's clearly a crucial way to spend time. And what's fascinating about AI and data centers today, like you said, is 2 or 3 years ago, nobody knew anything about data centers. But 2 or 3 years later, today, the common person is actually interested in a data center, right? Like data centers, like we're hearing about it all the time. And now AI factories, right? This dedicated data center for AI. And so with Lucend, this is a constant analysis of data to say, okay, how do we tune this incredibly complex system where it's so hard to comprehend just how much energy is flowing into these, into these buildings. And I can imagine the complexity that comes with that. But honestly, we don't know. I don't know. But clearly it's like incredibly complex to optimize. And that layer, which is really such a huge opportunity because your company's growing so fast. I mean, you're now on multiple continents, right? You're in multiple countries. So what is the conversation like that you have with a data center company when you're approaching them to say, hey, we can help you optimize? And maybe the question I'm asking, Jasper, is, are they coming to you? Or like, how are you selling into data centers today? What conversation takes place?
I think the data centers are aware of the conversation that's happening now in society about data centers because everybody now has at least an opinion about it. So actually what now happens is data centers are coming up to us and saying, hey, we get it. And we know that we might need to change things. Let me give you an example here is that data centers are the type of industry that has always been focused on doing things as efficient as possible. And the way to do it is invent new and more energy efficient hardware, like, for example, dry coolers on the roof. But I think they've come to realize that there's a limit, plus also there's an urgency right now. So there's a limit to the physical possibilities to improve those huge assets. And at the same time, the innovation needed. So there's a lot of innovation still going on in hardware, but the timelines do not match the need, right? So, for example, small modular reactors, SMRs, the capacity of those small modular reactors, they have a certain promise, but the capacity is not enough to deploy that technology in the data center markets today. And then we have a software solution, right? So what we do is, if they come up to us and say, listen, just give us all of the sensor data you already have, we make sure it works. And within 6 weeks, you'll already have the first recommendations how to make your data center perform better, more reliable, with less power, less water, less scope 2 emissions. And that promise of just 6 weeks by software that is insanely scalable, right? If you tell us, hey, just onboard this data center in Vegas today and onboard a data center in Chicago tomorrow, yeah, sure. I mean, it's not hardware, right? So it's really scalable solution. Is it the solution? Of course not. I'm not a believer in a magic wand that solves all of the promises, right? But I think this type of solution that we offer are a very important piece of the puzzle to increase the energy efficiency of the digital infrastructure.
Understood. Okay, and so effectively, I've read and Lucend describes as an AI agent. It's also not here to make the final decision. It's here to make recommendations to a team.
I think you now touch upon a very important topic to make this technology work. So recently I wrote a very interesting piece of research. And this research was about the current LLMs and how successfully or unsuccessfully they have been deployed. So Berkeley, I think it was a paper from December 3rd or something, so really recent. So what they did is they asked more than 300 practitioners, people building those LLMs agents across 26 domains. And they asked them, hey, how do you build them? What works? What doesn't work? What are your priorities? How do you measure success? Because what they found fascinating was that, and maybe you know this number, 95% of the LLM agents are not successful. So what makes the 5% successful, actually? This is what they wanted to understand. And they found out 3 things. And I'm going to mention this as an example because it's the same for our industry. So what makes those LLM, what makes that 5% successful? 1, they are not fully autonomous. 68%, the study found, are deliberately limited to 10 steps or fewer before they require human input. And nearly half can't even do 5 steps alone. The second thing they found for those 5% successful agents, 75% require humans to validate every major decision. Right? So they need that human safety. And third, 85% of those successful teams just threw out every popular framework and they built everything custom from scratch and made it extremely simple. What this means is that the 5% that works needs human oversight, handles super specific tasks, and prioritize correctness over speed. So they're not like sci-fi autonomous, like they are constrained, supervised, and custom built. And the reason I use this very recent research is that we build our platform on the same things. What the industry needs is trust. First and foremost, trust in the types of solutions that we offer. We generate this trust, for example, by being completely transparent. So we generate these recommendations. There's all of the context in these recommendations telling you exactly what's going on in your data center. And our users can verify the context, right? So they can verify, okay, you're telling me this, I want to believe, I want to see it, right? Sure, here it is. And once they decide to implement, they can look themselves if the impact matches the expectation that was put forth in this recommendation that we generated, right? So very important. And 2026 will be the year to build that trust. I'm no doubt. 2027, I think we've bridged the trust gap by providing the transparency that the industry, that our user needs today in order to understand that the fully automated capabilities that we also offer are a no-brainer. So the fully automated capabilities, to be honest, they are done and dusted. Recently I read this paper from NREL 2021 where they describe in detail how they already automatically optimized their data center reaching a PoE of 1.06. There's already a lot of use cases where they show that what we do actually works. But this is why trust is the foundation for any move forward to more autonomously optimized data centers and manage that complex system.
So what I hear is trust for now, trust but verify. Or teams, they want to trust, and they also still want to verify, right? And so that's the tool that you're able to offer. Because as you're saying, as I understand, and I didn't know any of that, I appreciate you walking me through that research. It's really interesting that says that the successful LLMs really need that human engagement. They can't go too many steps on their own, otherwise they start to fail. Yeah. And it's specificity, and it's simple. It's an amazing technology, right? But it's actually, it still requires so much human engagement to really work, at least for now.
Let me stress one thing. Our AI, I prefer to call it machine learning, is different from what LLMs are, right? So I think what's now hampering the trust, what's now bridging that trust gap, for example, is that people now associate AI with LLMs. LLMs are just a subcomponent of a subcomponent, or a subcategory from a subcategory from a subcategory from machine learning from AI. But everything now is LLMs, right? So we take a different approach here. Do we do agentic? Yes, but it's a different sort of agents because it's, for example, reinforcement learning that also works with agents. So there's a lot of confusion, I think, in the space. Some companies saying, hey, we do agentic. Okay, agentic. It's not LLM agentic. It's reinforcement learning agentic. But the confusion there now is that everything AI turned into an LLM. We don't do LLMs today because they are simply not reliable enough, right? But we also do agentic. But it's a different sort of agentic approach here.
The output, though, is that I understand what you're providing. I mean, you've said it's almost like getting the daily newspaper for the data center managers, where they can get a kind of a readout, a snapshot of like, okay, here's what's happening in our facility. And as I understand what Lucend's able to do, or what that means for data center managers, is it increases their productivity as well. And if we're in a moment where everyone is still thinking about, do we have the right labor force? Do we have the right people? Can we get enough people? That this is also a really important tool that actually enables data center teams to be much more productive, which is also really a crucial piece of enabling this industry to move forward. Is that a fair thing to say?
Yeah, but also from different angles. So yes, one thing is more productivity, but the other day I read numbers like in the US alone, there's a shortage of about 90,000 electricians already. And when we look at data centers, there's more and more demand for very experienced engineers. So there might not be hundreds of people walking around in this data center as you noticed in Vegas, but there's still a lot of people needed to make sure that these data centers run. The second thing is that this year I was at a data center event, and somebody also mentioned the next few years 25% of the most experienced data center people will retire. So there's another layer, there's another urgency, so to say, to really focus on the people that do the operations in a data center. Also, those data centers become increasingly complex. With the scarce resources you already have, with the scarce knowledge you already have, you actually need more from both for current day data centers. And that's why I think a system like ours that is able to sift through, literally, we have like 300 billion sensor readings on our platform. And it's able to identify all of these patterns that we simply cannot comprehend. And having that sort of knowledge to be able to do your work better, more focused, but also with more risks. Because once, as a data center operator, you have a workforce that might not be enough or might not have the knowledge that you actually want, how cool is it then to actually have this, to be able to tap into this intelligence that is able to help you and at the same time be completely transparent, right? It's not a black box, at least not our solution. One of our operators a while ago already said, oh wow, to all my new operators, I'm going to train them on your tool because they now understand how this facility actually works. This is, I think, also a beautiful addition and a very relevant addition in order to be able to operate your data center more effective, but also with less risks.
Mm-hmm. That makes sense to me. I'm curious to hear more about where the company is today in terms of where you're operating. You're clearly operating in what is the, if not the, I mean, JP Morgan projects $5 trillion in AI infrastructure investment in the next 5 years. So you're smiling, obviously that's awesome. You're sitting in a very, very lovely spot in that regard. You work with, I know, at least I've been able to see you work with a company like Digital Realty, one of the major global data center operators, where you're helping them achieve some of their very ambitious goals toward carbon neutrality for emissions by 2030. So talk me through where you are today in the market, What's the footprint of the company? You mentioned that by the number of data centers you're in, or what does that look like today?
We work for companies like Digital Realty, T5, for example. We have the data from almost 50 data centers on our platform. Data centers from Melbourne, Australia, from Singapore, from Frankfurt in Germany, Paris, Dublin, Chicago. And this really allowed the company to grow our intelligence because of all of these data centers operate in all of these different climate zones with all of these different data center designs, right? So we optimize data centers that even use river cooling, for example, the exotic forms. So what we're offering today for customers, again, globally, is already a suitcase filled with all of these optimization models that whenever you come up to us and ask, hey, how can you help us? Sure, if you have a chiller, we already have a whole bunch of optimization models that optimize your chillers from all of these different angles, right? And it's not just the chiller that we take into account, but our solution actually focuses on the data center as a complex system. Right, so we don't optimize chiller number 13 because Schneider, to your point, Schneider probably has the intelligence to optimize chiller number 13. But chiller number 13 probably optimizes itself for maintenance, for example. But I actually want to optimize for PUE, and I want to make sure that the whole data center gets optimized, right? So chiller number 13 might well make a different decision for itself than for the system. So we've collected a team of about 30 people today, with beautiful backgrounds in one of our people even has a PhD in a very complex topic that I can't even talk about because it's so complex. She finished her PhD in 2 years and she only wanted to work for us because of the work that we do. And that was the foundation. And what we have today, we have a new version of the platform, much more scalable, that we built last year. We're now deploying it globally, but most notably the US. Our focus today is really on the US for a number of reasons. And one, the US is the biggest data center market in the world. So all of that, it's not just all about the money. I think it's also the fastest growing market. And there's quite an interesting few things happening here. And we're happy to contribute.
I love it. So it sounds like as you're describing your growth, now 50 plus data centers growing, it sounds to me like your competitive advantage, so to speak, or the power of your system, it continues to get more powerful the more you grow because you're ingesting more data from more edge cases, river cooling, whatever it might be. The whole model gets just so much smarter, which then helps the next data center and the next data center to be optimized as well toward that PUE number becoming more and more efficient. Is that
exactly?
As you think about your Lucend's aims, objectives, impact, obviously growing a highly profitable, fast-growing company, how do you think about it from a carbon perspective and a carbon emissions opportunity?
I think maybe 2 or 3 years ago, I read the Microsoft Sustainability Report, and it was the first report where they admitted, hey, we can't commit to the 2030 climate neutral goals anymore because of our data centers. But it was not because of the CO2 emissions from running the data centers. It was all due to their scope 3 emissions. All of the hardware that goes into the data centers. So that's where their biggest challenge actually is. How that plays out in the future when these data centers ramp up, of course that will change. So that also got us thinking. That was already like 2 or 3 years ago. And what's really fascinating about what we see every day is that we run a lot of optimizations that are related to maintenance and actually being able to increase the remaining useful life of the assets that are there today, offering new possibilities like usage-based maintenance or usage-based replacement decisions in a data center. And it's not just whole chillers, for example, but also the components like valves, fans, compressors. Should we replace them or not? Being able to tap into that data, spit out all of these recommendations on that point, we're actually also making a dent in these scope 3 emissions that today drive most of the emissions from the big players because of all the hardware in there. And getting back to the business side of things is that replacement decisions drive millions and millions of dollars per year per data center. So this also has a very positive upside for the data centers themselves, because they are able to extend the remaining useful life. They are able to make sure that they tap into the potential of predictive maintenance, which makes them also more reliable. Prescriptive maintenance, because of this complexity, we are able to prescribe exactly, maybe you see a symptom here, but the root cause is here, so please focus on this one. So reading that report about the Scope 3, we've been able to focus on those Scope 3 emissions for the past few years. And that, to be honest, every day feels like we're uncovering another opportunity, whether it's direct emissions, reducing power consumption, reducing water consumption, or the Scope 3 emissions by tapping into asset health, maintenance, remaining useful life, and all that. Yeah, that's a really fascinating story. And it also makes us feel like we've just begun, to be honest. We've just begun to uncover all of its full potential.
I actually wasn't aware of that. So the clearest value, that is the most visible value, is like, okay, we can optimize the energy that is being used in this facility, like per the output, the PUE as we've talked about. This other piece, right, when we talk about Scope 3, all of this stuff that actually makes a factory, right? All of the valves, all of the rack, and like how much energy goes into making that stuff in the first place. And then what happens, like if you got to get rid of it and go buy something else, all of the carbon emissions associated with all of that, like the embodied carbon, which we just never think about. What you're alluding to and what Microsoft's talked about and others talked about, like that's the biggest footprint. That's responsible really for more carbon emissions in these now moving to like gigascale AI data factories. And I think that's hard to even appreciate because the whole thing is so big, right? It's all on such a massive scale. We don't even know. So I hear you saying like you're starting to even understand what is the opportunity to extend the useful life of what's in a facility and what that means from a carbon saving perspective as well. It's just,
and maybe let me give you a very, very specific example here. So one of the optimizations we do, and again, it's not at specific asset level, but here at room level, right? So we try to optimize the energy consumption in the specific data halls, IT rooms. There's different terms for the same thing, the rooms where the servers are. Not in the AI factories, but in the existing air-cooled data centers, most of the time there's cryo units. But what most people don't know is that servers are on the raised floor tiles. So there's a raised floor, and the cold air towards the servers is being blown under the raised floor towards these servers. So there's these cryo units, and these cryo units have big fans blowing the air towards the servers. So we have this optimization that looks at these cryo units, looks at fan speeds, valve openings, floor pressure set points, temperature set points, SLAs, right? So the temperature needs to be a certain amount of degrees reaching the servers. Then we have technical information about these cryo units, often the fan speed power curve. It has a non-linear relationship with the power consumption. So at a certain level, as they start to spin faster, the amount of power increases exponentially. So what these models do is they simulate in the backend what happens with the average fan speed of these cryo units if I turn on a cryo unit, if I turn off a cryo unit, if I turn on 5 cryo units, with the combined energy consumption of these cryo units in the room. And what we often find is that turning on cryo units actually saves a lot of energy. Because if there's more on, the fan speed reduces because there's more assets in the room. Makes sense when I tell it, but our models are able to calculate exactly like, hey, now you need to turn on 6. Maybe tomorrow you need to turn off 2, and maybe the week after you need to turn on 4. Because it tries to simulate here. And then getting back to the maintenance and the Scope 3, what it does, because it reduces the speed that these fans are spinning, it also reduces the tear and wear and extends the remaining useful life of these fans. So these are just one example of all of these examples that we have where actually maintenance, Scope 3 are going hand in hand with direct power consumption. And that's, again, getting back to what I just mentioned, it feels like we're just getting started, to be honest.
Yeah, I love that. And I really appreciate that example because it does give me a sense of what it means, what your solution can do. And also it helps me understand the complexity, and it helps me think that you're describing one system and it sounds fascinating and how you can optimize it, and recognizing that there are so many other systems within that facility that also need that same level of optimization, it gives me, I think, a better kind of picture of what it means to have Lucend in a building.
I still remember the very first time we just got started and we had all of this sensor data in. And back in the day, I graduated in decision support systems with complexity theory or case theory, where the butterfly flaps its wings in Japan, causes a hurricane in South America. And the data center is a complex system in itself. So the first data center ever, we looked at the data, and I still remember, I still have it somewhere, I should have it, I hope, is that something happened at the roof, something happened at the chiller, and we could see the system respond in the rooms, all the way down to the rooms, all the way down to the valves of certain assets. So the first ever direct relation in this insanely complex system that we found. And this is the complexity that we have to deal with when we're trying to optimize this data center, is that something happens on the room. And it has an impact on components of assets in the room. Very fascinating to be able to work with all of that data and try to understand and continuously improve every day.
Amazing. And so on the business side, is the business model a SaaS model?
A fee based on the IT capacity of the data center, yeah.
Got it, okay. What sounds so amazing, Jasper, and getting a chance to talk to you is that there's the business opportunity, there's the demand, and yet it's also, as you're talking about it, it's so cutting edge. And there's still so much to discover and figure out where this is really going at the same time that you're offering this product to market that is already delivering all this value. That's really amazing to me.
So when we started to investors, I think we are very fortunate enough to experience a lot of inbound traffic from investors, to be honest, at a point that even becomes overwhelming. So we were talking, and investors obviously want to know, hey, the value, how does it work, and what do you do, and how does it drive value? And I still remember with my co-founder René Gompel here, we sat down and we were drawing up all of these things, and suddenly we found a direct link between what drives our team, and that's, let's say, saving megawatt hours of energy, a direct link between that and our customers' goals. Because every megawatt hour that we save has a positive benefit for our customers. So we are fortunate enough to be working with a type of solution that we can link societal benefits or sustainability benefits directly to monetary benefits, but also reliability, risk decrease for our customers. And that was the first time, this was like 2 years ago. It was like, oh wow, this is cool. Because if we have this metric, right, so this is how many megawatt hours that we've saved. We can focus on that metric, for example. So we don't have to focus on how many dollars did we save. If we have that metric, or we have the water, or we have remaining useful life for that matter, those are the metrics that we can work with, and we know it drives value for our customers.
Those are the most beautiful kinds of business models, right, where it's like, what we do to actually cut energy, to cut carbon, if we focus on that, we know it delivers value. We know it drives, savings. Yeah. It goes right to a customer's bottom line if we can do that for them. So let's go focus on this thing that we want to do and we exist to do, which is to really make that space run as efficiently as possible.
And maybe to give another example how impactful these recommendations are, we onboarded a facility in Paris, and out of this big data center, there were, for example, 2 devices called UPSs, uninterrupted power supply. And these 2 wasted as much energy per day as a household uses in a year. That was just 2 assets out of the thousands that are in a data center today. So this is how impactful our optimizations are working in the data centers. We never talk about kilowatt hours. It's always megawatt hours that we're able to save.
I love it. Jasper, I am so glad I got a chance to talk to you. I have learned a ton today. This is so enlightening for me. And it's really fun, I think, that this conversation about climate and AI, and it's really cool to see how AI is becoming such a part of this overall conversation in terms of how do we get to that clean energy future? What are the solutions that deploy? And I'm so excited about what y'all are doing with Lucend. I really appreciate the chance to speak with you about it.
Yeah, thank you very much.
And thank you for listening. If you're enjoying Supercool and appreciate our conversations that merge climate, innovation, and commerce, please take a moment to subscribe and leave us a review. It's the best way you can help the show reach other future-forward decision makers who would benefit from these conversations too. See you next time.